Welcome to another episode of the Confluence podcast. I'm Randall Stevens, and of course, I've got my sidekick, Evan Troxel. Today, we're happy to have Michael Jansen and Dr. Prasanta Bose from TwinMaster with us. So we're going to dig in to everything that they've been doing with TwinMaster. Welcome, guys.
Thank you. Well, it's lovely to be here. I appreciate the invitation.
Let's kick this off. Evan gave the kind of background of you two. So, I'm assuming, Prasanta, that a lot of what has gone into the thinking that became TwinMaster originated with your work when you were doing work at Starbucks, or maybe even all the way back at Lockheed. But maybe give us that. Let's start there with kind of the background. What led to the development of TwinMaster? What was the impetus for that?
Yeah, I think, it dates back maybe even earlier. Basically, it dates back from my graduate days, working with people like Andy Bartow, right? He's a Turing Award there, and Rich Sutton, reinforcement learning. It's all about intelligent systems. So that thinking matured, or you can say, took more. You can center and front in Lockheed Martin. At Lockheed Martin, if you look at it, it's a systems world of space systems and aircraft systems, and with my interest in making them intelligent, right, led me into, you can say, this overall different areas, but primarily to do with how do you make it autonomous. The cost is a big driver, right? So when you're looking at, instead of having one satellite per mission, how do you make it a reconfigurable satellite? So you're looking at kind of a self-configuring kind of a payload. That's one concept, right? All the way to how do you look at formation flying of a set of drones. In this case, it was satellite kill, right? Because I was playing a major role in this thing called MKV, multiple kill vehicles, right? How do you define a kill basket, and how these guys self-organize depending on, what's the target, what's the flare, right? And go after the target. Because, so there's these very hard problems of control coming in, intelligence coming in. How do you share the information? How do you self-organize? So that was one. And then the other part was I was simultaneously doing a ton of, you could say DARPA-led and NASA projects. And NASA, basically, this thing was part of the earth science, looking at, monitoring the sun's weather, climate, the flares, how that influences, the Earth's climate and weather, as well as kind of thinking about how you monitor forest fires. Out of that born the notion of digital twins, right? The reason was, this is where I was thinking that as if the satellite was sensing the data, if I can make it a kind of a virtual twin, which is addressable, giving me, queryable, questionable, right? Anything, the task I give, as if you got a hardware, the satellite is watching over something, as well as the data that is giving you the intelligence, and then being able to coordinate. Let's say something where lightning is happening, somebody is speaking on some data about, what's the dryness of this place, right? So this gave rise to this, you can say, this digital twin construct, right? And this was early, way back when I first started, literally maybe 2 or 3 years into Lockheed, close to 2000, right? It went on to develop into looking at Lockheed internally as we were, creating these, you can say, very complex systems where people were basically keeping things in Excel spreadsheets and complex MATLAB models. And so there was no way to kind of connect in a seamless manner. So I thought digital twin is kind of the DNA, right? If I can keep the kind of the intelligence there, and as people are working with it, is giving you feedback. So there are these things that developed from there onto, as I started applying into these DARPA things of self-organized using robots, right, called landroids, right, where they would, you set them in a building and they self-configure to maintain a network. If somebody dies, they take over, right? So if you look at these, you can say at a macro level of, things that was seeded way back in when I was doing at UMass, working with people like Michael Jansen, Then there was another person looking at, the cybernetic model of the brain. Okay. How does spatial reasoning occur? How do you, and I was even looking at, I was taking courses in neurobiology of learning of how does basically a rat, runs a maze kind of thing, right? What gets what? What's reinforcement learning doing to it, right? And my thesis was in that kind of thing. But anyway, so these constructs at Lockheed, it was primarily to make scalable autonomous systems which are self-organizing and can actually work independently, with obviously human in the loop, right? There was other kinds of things that I did while at Lockheed, there's like very large-scale sensor networks, these small motes they used to call, came out of the Berkeley, thing. Very tiny devices, you spin them in thousands, and they self-configure, right? Out of that came different, I was doing a lot of, I would say, very creative thinking, I would say, very entrepreneurial thinking, okay. And because of that, I also thought maybe, every time I was doing this proposal, and it's like a cradle to grave kind of thing, you come up with the construct, go for the BNP money, do the project, bid in a very intense competitive environment, right? And then go on to, deliver on it. It literally, like a field demonstration. I said, you know what, let's do a stuff, get on and do 10 of these ideas in a startup. That's where I basically co-founded Falkonry. It's still active. I'm also part of it, right? And from there, I went on to Starbucks. Starbucks is, again, looking from an angle is that because my training had been into looking at these different disciplines of the systems world, right? I forgot to tell you, at Lockheed also, I had the fortune of basically getting this Lockheed-wide, you can say, one person being selected to go to Santa Fe Complex Systems Institute. Again, looking at the big picture of the world, right, as a complex systems, as a network of things like the brain, think as if working as camera. I learned a lot about things. So same thing when I went into Starbucks, say, hey, this is thousands of stores worldwide, sending data, delivering to coffee. It's a wonderful macro brain. If I hear the brain of Starbucks, and I said, hey, every coffee that goes out has the right quality. I have visibility, what a store is doing. It's like the coffee to a digital, IoT, kind of a twin of the store, and then a macro, store, right? That gives you visibility, which store is doing well, right? And so on, right? From there, Starbucks, I went to Acuity Space, right? Acuity is building its lights. You've heard of all the big airports and everything, right? So from there, at Acuity, I was doing two things. It's like this thing to do with how do you price? What's a computational pricing engine? That's one. The other one was again making the lights themselves intelligent, so that consider basically Walgreens and you are moving around. They can tell. You can collect intelligence which part of the aisle is getting heavily visited, so that you can reorganize and make easy for the customer, right? So the underpinning of all of this is this notion of creating twin as a way to model the environment, and then it has a life of its own. So it's both a structure and obviously intelligence behind it. And out of this born, I met Michael to create TwinMaster. And it's a brilliant, because it's I would say convergence of multiple disciplinary ideas. And there's a core theme, going through that thing of how do you create smart systems, intelligent things, so that you make them, a little life easier.
I guess my first question I'd like to dig in on is, for me, it's easy to think about the digital twin being a mirror of a state of something, and then data, IoT data or whatever can be attached to that. So I get that part. Explain a little bit more about how this idea of that the systems are reconfiguring, or is that just the idea that it is alive and the state is changing all the time? Can you?
Yeah. So, right. So the view is like this, right? I always view for the world from a control theoretic standpoint. That's also we do, right? It's like basically I call it as the plant layer. Plant is basically just like the robot, actuating kind of thing, right? Or even a manufacturing plant producing stuff. And then there's the cognitive layer, right? Or you can say the intelligence layer, right? So there's a feedback going on. So think about this IoT or twin that you're building has both these aspects in that. There is the part which is a sensory layer, giving you the information that is coming in, streaming in, right? You're doing analytics, you're forming a model of that thing. Because without model, you cannot do model predictive thing. Because at the end of the day, we, right, form a constructive model of that world or space, right? So that we can work, we can act in the world in a proper manner. So when you look at the twin, you got both sides of the story, right? The intelligence layer and the sensing and actuation layer, right? In order to make it a real twin, because at the end of the day, you're making the digital twin to empower. You're now creating a system, just like if you take the brain off, right? We just you got the substrate or the physical substrate, right? So now with the digital twin, the digital layer, right, which has both the sensing part, keep in mind, right, because that's an important thing, and accuracy, right, and that intelligence, which is basically making sense of the data that's pouring in from the sensory data, forming a model, and then closing the loop. Hey, what should I do?
Yeah, I was when you were first describing that, I guess my, even with what you were talking about doing with Lockheed, it's like one of the things I think that at least I think about with the digital twin is it lets me run simulations, it lets me do things, but really that cognitive layer is just an advanced form of that,
Exactly.
Yeah,
exactly.
So
I mean, that's when I took that, move that forward, because I was motivated that it's basically, again, going back to the central idea that in order for me to act in the world, I need to have a model of the world, the physics. So you have seen, for example, this theory now going in, where is the limit of AI, right, kind of stuff. Does it have a stateful model, right? The reason is this what they call in control theoretic world called model predictive control. That is, the model is predicting what is going to happen to the state, the history, based on the past history, right? And there are different constructs in that model. It comes out of deep control theory, in aircraft everywhere, right? This receding frontier. The frontier is moving because the world is dynamically changing. But your model is tracking that and saying, hey, the next this thing happens, this is gonna. Then I'm prepared. I'm not reacting. You know what I mean?
Yeah,
okay.
Yeah.
Sorry. I keep in mind.
This is cool. This is the fun stuff.
Get me excited.
I'm
going so we need to, right?
Well, I think
you have to give it control.
You've obviously been, you've been working on this 25 plus years and have a level of understanding about it. I'll just say from practical, but academic as well. It's hard for some of us to put language to it in the right way. We kind of sense it, but it's hard to. So anyway, thanks for helping to explain that.
No, but what you're asking is also because I also wrestle, right? I have found, because I've studied, I used to study a lot of philosophy, like Women, Fire, and Dangerous Thing by George Lakoff, right? How does, semantics grow, right? Mm-hmm. How does, if you look at the neuron, anchoring that is going on, right? Because I was doing deeply when I was doing my PhD, I was vacillating between, should I go into this area of learning and neural computing, or should I be living in the logic layer? There's this logics of reasoning, right? So anyway, but I had to wrestle and get a visceral understanding, what I call as, can I visualize how is this working? Mm-hmm. You know what I mean? And I can explain to myself. Otherwise, I cannot bring it.
Right. You got to have a mental model, right? To
exactly. What you just said, I keep on asking these guys, do you have a mental model of what you're programming? Right. Do you understand what if you're talking about an AI agent, do you have a mental model how it works in the world? How are you going to, if you don't, you wouldn't have any freakest idea to how to create something new out of it.
I don't know if you all heard, I was watching one of the all hands meetings last week that they broadcast from XAI, but they were talking about the advanced in their model for coding model. And then after they talked about that, Musk said he thinks by the end of the year that they're going to be skipping the code and basically producing a binary. Like the AI will create a binary. There is no code. So it's like, it's just hard to wrap your head around. Like, it's basically a neural net is going to have an input and output, and you have to be able to test against that.
Yeah.
Anyway, it's just interesting.
Yeah. No. I mean, at the end of the day, right? At the end of the day, if you look at it, right, fundamentally, what has happened is that, that expressive world of language, image, and everything, right, got tokenized. That means vectorized, right? Okay, you've heard these things, yep. Right? And being embedded, right? And through this encoder-decoder architecture, it is generating a text which is consistent with the context and what you get, right? Yep. I mean, I'm not getting into the mechanics of how that happens, but that's the reality, right? It's got codified. It got combined.
Anybody that's in technology, good technology and good software should be indistinguishable from magic. It is like magic. You're feeding this stuff in, and it's like, how in the... Anyway, Evan, you had comments. Or
maybe Michael can chime in and just give us kind of the vision of TwinMaster to set a little bit of context.
TwinMaster was conceived as a company that could figure out how to apply AI in the AEC space. Prasanta didn't talk a lot about his AI background, but he has 2 PhDs in AI, and it goes back to the 80s. He's been at it for a very long time. And he's led initiatives in AI for, I guess, 35 or 40 years now. 40 years, it's been a long time. My previous company was a company called City Zenith that was dedicated to trying to apply digital twin technology at a city scale to help cities to become more efficient. And one of the things that we struggled with and didn't have at the time we were building that company was something like AI. So by the time I met Prasanta, we said, we really need to we can rethink everything that we're doing here because AI is going to change everything. So how do we develop a product that can leapfrog these existing design authoring tools that are largely algorithm and deterministic and into this world of inferential AI that we really think is going to be the future? So TwinMaster was born as an idea that we could create this type of copilot that we could embed into existing modeling tools that architects and engineers already love to basically amplify them and make them smarter by allowing the copilot to do all of the complex, what we call multi-objective reasoning or the thinking. So today, a lot of what you see in some of these tools, they will have plugins that will, for example, optimize an energy model or a carbon model or a constructability model. But the way that architects and engineers think is really all of these KPIs at the same time. So you have to develop a tool that can think across these different performance metrics and then reason on top of them to be able to give you the kind of optimal output. So it might then need to be able to consider carbon and cost and energy and maybe a comfort condition all at the same time. So how do you do that? That was the thesis behind TwinMaster. We didn't want to replace the existing modeling tools. We think there's already too many modeling tools in the market as it is, and they have very large entrenched audiences of millions of existing users. So in the beginning of the company, we thought maybe we would just try to, somehow elbow our way into that market by seeing if we could develop an independent product that would eventually become a kind of effective another kind of design authoring tool. But as we got deeper into it, we realized that we were better off sort of amplifying and supercharging tools like MicroStation 3D and ArchiCAD and Revit. There's other tools already out there. So ultimately, that's how we began positioning ourselves.
Was that a forced decision or just a kind of a business model decision, right? To build your own offering.
Yeah.
Let me answer that. It's actually,
okay, go ahead. Yes.
It's a fundamental question. And very well asked. We really didn't see a business in starting another design authoring tool.
Because there's several, right, that are on.
There's so many.
Yeah.
We need not name them. There are so many. BIM 1.0 and BIM 2.0. multiple tools. We actually did a hard look and hired a third-party consultant out of New York to study the market for us and to report back to us what was the actual uptake in the market of all these tools, from the big ones to the newer ones, right? And what we found was that the BIM 2.0 tools just were not getting uptake, and still. And we felt that we kind of asked a hard question, why is that the case? And then we started talking to CIOs and CTOs around the market, and they would tell us, we just can't afford to rip out tools that we've already relied upon for years. There are well-established ecosystems around these tools already, training protocols. It'd be very difficult to remove these tools, and they are improving incrementally as it is, so it's not as though we're unhappy, even though perhaps some of them could be better.
Yeah.
But what we felt was missing was in trying to apply intelligence to the way that these tools are being used. So we felt maybe it's a little bit smarter to partner with them than to compete against them. It was just a fundamental decision that we made. So in the beginning of the company, we were terrified to go up and talk to people at Autodesk and Bentley. And you mentioned earlier McNeil, Trimble, Nemetschek, Chaos, some of these companies, because we didn't know, we were a small company. We didn't know if we had anything to offer, to be honest, and if we could even be considered as a potential, another player in their universe. And so we very gradually, we started socializing this concept in the market about a year ago. And then we stopped hiding from everybody and actually participated in a few shows. And we took part in the AIA show in Boston about 8 months ago or so. And we won Best Innovation of that show. And what surprised me is that 3 of the big 6 AEC software companies came over to meet us. I mean, at a senior level. There was clearly curiosity. And we realized we actually had something in hand with our approach that was unique and significantly far enough ahead in the market that they would rather partner with us than try to rebuild it. I think that was the beginning of this new model that we adopted, which was, let's partner, let's embellish existing tools that already are in the marketplace. So since then, that's been the path that we're on. I think some of you know that last week Bentley announced a global partnership with us publicly. There will be more. I can't announce them all right now, but we think there's a very strong chance that we'll end up working with most of the major AEC software players by the end of the year. And what we're doing is we're developing an integration with them first, which allows us to connect to their ecosystems of tools. And typically they have some type of data hub or data lake type product, like a Trimble Connect or an ACC or an iTwin. And then they have certain popular modeling tools. So again, we did research to see which of these modeling tools are popularly used. And we looked at each company and said, okay, they've got this, this, and this, and we started to focus on those first. We became an Autodesk technology partner in November of last year, which was the first formal, I think, arrangement that we made with any of them. And now it's kind of, I can't name names yet because it might be a little bit ahead of where some of the marketing teams are at, but there's a strong chance that we'll be working with everybody before you know it, And so that allows us to focus on just making Archie, our copilot, as good a tool as it can be, rather than trying to recreate these design authoring tools that are already fairly successful in the market. And that's where we're focusing.
Do you end up pulling that data geometry, but also metadata, like into your own neutral database or place to do the processing?
So if you basically the key underlying principle by which AI works, right, is this aspect of semantics, right? The generalization or specialization, how the KQ mechanisms work under the hood of an encoder decoder, right? So semantics is important, right? So therefore, if I want to create a general purpose engine like Archie kind of thing, I need to create a kind of you can say that annotated, semantically annotated model, right? So that it becomes a common layer, what you just said. Right? That is because I can get from
multiple sources,
Bentley,
yeah.
I can get from Autodesk, right? And the other thing, this is the most important thing, which almost is one of the lessons learned, right? Because I have always understood, always thought, right, by viewing these kinds of human you can say created artifacts as systems, right? Systems gives you an ontology of components, connections. They are evolving over time. They are spatially kind of thing. All of that semantics gives you can say a good way to exploit that semantics, right? The causality in a systems world, right? The dynamics in a systems world, right? Some of this is not present in what is in this thing, right? But in order to bring that richness of AI reasoning, right? Whether I'm saying, hey, why should I be having this kind of a duct at this kind of a thickness? Hey, is it going to be a pressure drop? I need that systems thinking of breaking it up into, you can say, subsystems, right? Their components, their relationships, right? And then being able to reason about them. So you're right, absolutely. That's one of the primary motivations. So when we are sucking in a model, we obviously create a more neutral representation that is more augmented with these kinds of, you can say, the semantic aspect, system-oriented aspects, as well as decomposition. It's also a fundamental to how we scale, right? In terms of, I'm just going a little bit again deeper into why rationalizing, why do I need systems? That if I'm going to basically think, I'm going to mirror the world of the architects, the builder, the guy who's doing plumbing, or the MEP engineer, they work in the quote-unquote subsystems world. They have relationship, right? So the notions of concurrency, that asynchronously each one working present. So is the representation designed like that allows you to work in there independently and synchronize and collaborate and cooperate where there are connectivity, right? And so that's another very important thing, which basically is like saying, by design, we are creating a system that is geared for reasoning by multiple agents as surrogate. They can do teamwork. They can, infer, and they can find out what's affecting what, right? So those, you can say again, you when you think about architecting an intelligent system, and you want to see, hey, this world is a physical system. I'd better represent that in that manner. Then I can be actually, literally, you can say, proactively thinking future-wise of TwinMaster. It is by design, has some properties that will help it to grow and become more and more effective.
I have a question about the kind of fundamentals, because Michael said something, and then you've all added to it about thinking about TwinMaster as a company from a new perspective. Because of you saw the technology in the future that was coming, and you wanted to build something that could leverage that in a new way. And then I think about architecture firms and construction firms and engineering firms that are very legacy. This is the way we've always done it. And I think about incentives. And so this, Randall, you can cut me off if you think this is another podcast, okay? Because it might be. But the incentives for architects and engineers is to build a set of construction documents. It's not to build an operations model, which I think is more what you're talking about. When it comes to digital twins, right, that totally makes sense, right? We're talking about getting a building permit based on abstracted two-dimensional drawings from this three-dimensional model, and then architects are done, as soon as occupancy happens, and next project. And then the owner is really the one kind of, facilities, operations, and management is taking over, and maybe they're the ones who are, obviously there's maybe a different business model in the future that architects could leverage, but for the most part probably aren't going to. And so therefore, the information that's stored in their models may not be as conducive to the things that you're talking about as ideal. Right, because it's like, well, the goal here is to get drawings, and then we're going to build the thing. We're going to use that as a set of instructions to build the thing, and it's not maybe the same model as a BIM model during design. Maybe it is, maybe it's augmented. I don't know, but I'm just curious, like from your perspective, when it comes to the way architects and engineers do things, do you see enough of what you did with TwinMaster, which is rethinking the company or the process of how we do this based on the future technology that we see.
Exactly, and it's
Let's
very interesting.
That's an excellent question.
No, this is an excellent question, because this is I have kept on drilling into it with every day, 1 hour, 2 hours. I kept on, and it is. I mean, I didn't know Frank Gehry, to be honest with you, but when I read his works, the way he worked, it gave me a strong validation of the thinking. That is, if you design, you would, and this is also came for, again, out of Lockheed Martin, right? When you're creating this multi-billion-dollar, very, cost-intensive, mission-critical, safety-critical system, you better design for that. That means it is projecting into the future, just as I was talking about more predictive sense, but in an operational, in a history, in the future sense, right? You need to basically, is this feasible? Is this guy going to be buildable by cost? Is the material there? Is it basically, taken care of with respect to, these regulations? The reason you want to do that, and again, this is lessons learned. I heard the hard way, right? I was asked this backtracking. You do not want to backtrack and fix very costly mistakes in your design that is going to bite you during construction phase, during operations phase, right? So this forward thinking, right? I mean, you're thinking ahead of this thing. And you can fold in. You're just like, the people use the word called front loading or whatever you want to call it. But being able to take that into consideration. I mean, obviously, you're going to go in a lazy manner, right? And you'll hear this economic story that is, they call it as, that is, you don't want to over-engineer, you know what I mean? So it's like this options market kind of thing, which options you want to exercise that is good enough, right? But yet gives you that 70 or 80% this thing so that you are really protected, okay? And that's what has been the central thesis, I mean, of my, you can say, training. I try to train others, in that thinking of, when you are designing, when you are creating the twin, or at the early stages, think like that, right? And so when you're when you're saying, hey, what is the energy demand? You're saying, hey, what will be the occupancy of this building, right? What kind of environment is this guy located? What are the buildings that may possibly grow, right? You're modeling, you are basically, you're doing an active model construction. And based on that, you're saying, hey, wait a minute, based on, what the current site, the project is, right? And the environment around it, these are, you can say impacts, right? And this is what you're going to make decisions based on that effects.
Yeah, I'm an architect by training myself. I spent 11 years in the profession. 5 years with a company called Portman & Associates that got sold recently after many, many years. But back in the day, it was big into hotels and mixed-use developments, all driven by Mr. Portman himself. And then I went to the interior side and joined Hirsch Bedner for several years and began working on luxury hotels all over the world. So I got a lot of hands-on project and construction experience in global projects that were upscale, typically city center things, and learned all the problems architects faced, from concept design to delivery to permitting to translation on site to having to translate things across borders and having to work with design institutions that were responsible for making construction drawing. I mean, all those issues. I think when we created TwinMaster, just a few points I want to make. One is that primarily the goal was to try to make AI easy to adopt for architecture firms. Simple, natural language prompts, no need for scripting, no need for additional plugins, and allow them to keep using the tools they were using. That was fundamental to us, because we saw a lot of other things out there that were saying, hey, try my new platform, and you have to learn this, and you have to learn that. And there was a lot of pushback against that from incumbent firms saying, we just don't want to switch. Because as you said, our job is to get high quality projects out the door that are well documented and done on time and to a certain standard. I think the other thing we were interested in terms of the process itself, is in trying to improve that, the trade-off process. I mean, architects are constantly evaluating this versus that. And so this concept of multi-objective reasoning was designed to make the design process fast, accurate, and comprehensive. So you could actually consider a multitude of things simultaneously, quickly, and accurately, which, as we know, I started on hand drawings. I predate CAD. And because I was a young guy at the time, they took all the young guys at Portman and made us learn CAD and teach the older guys. That was just what happened to happen back in the day. So I started at MicroStation and eventually moved to AutoCAD. And so then I founded a company called Satelier that provided CAD and BIM services to what ended up being 30 of the top 50 AEC firms in the world. And we had to have all these different tools in the office because these companies were using all these different tools. So we had a team on MicroStation, we had a team on AutoCAD, we eventually switched to Revit, and by 2007-8, we were 50% BIM services, all that kind of thing. So I became very familiar with the challenges of the process, and we just really wanted to make it more efficient. And that kind of, we had this idea that eventually became AI, and when I met Prasanta, I said, honey, we have to figure all this out and see how we can apply what you know to the building sector in a way that architects and engineers don't understand. So there is a practical application of this in the design process itself that cuts planning time significantly, that reduces rework significantly, that reduces the need for microsimulations dramatically. And
so you're pulling those later, what maybe we would have considered later stage things earlier into the design process
100%.
So that they have impact on the outcome.
100%.
And then it can go farther after that.
Absolutely, which leads to my third point, an excellent segue. I do believe that architects need to think about other business lines. And one of the things I think that they can eventually consider is being in the digital twin business, because they actually give birth to the original digital twin models. And I think there's a business to be created out there that would be substantial for architects to offer digital twin as a service, because they actually developed the twin in the first place to the owner, that can be sold in perpetuity as a residual of some kind that they could manage, that they continuously update, all that type of things, so that they can move beyond the world of fixed fees into a world of residuals. I think we need to see architects going that way, into rethinking how they make money. We've all seen how our fees have been cut. The little contractors taking more because of BIM. The owner keeps pressing us down, and it's squeezing us to the point where it's getting hard to do our work. Architects work crazy hours because they're under constant pressure to get jobs out within a certain time frame and to a certain quality. That's not going to change. But I think what can happen is they can begin to spin off new business lines as a result of the intellectual property that they're creating. So I'm hoping that we can put AEC firms, specifically architecture engineering firms, into the digital twin business someday, and that's one of our goals.
And I think to add to that, Michael, it's actually an opportunity for growth of architects and engineers. Okay, I'll tell you why. Again, if you think about the complexity of the world, okay, in which this building is going to be placed, they are constantly confronted with articulating their questions. Obviously, in the parlance of prompt as a framework, they have to articulate. You know what I mean? Hey, what's the problem? Why does it impact this? They are constantly rationalizing the decisions from these multiple dimensions, right? So in doing so, right, it is not actually, you can say, giving away the knowledge to an agent, but taking that and getting these agents, help them out. They have just now make it a first-class concern. You see what I'm saying? That is now present in the kind of, you can say, the reasoning that went behind it, the stateful, scene representations, the causal graphs being created. That is now they can use for the subsequent answers. They are becoming more themselves educated, right? And the products they're creating as a result of that is going to make them more powerful. I mean, how would I say? They will unlock that creativity.
It is
much better.
It's the ultimate manifestation of the master architect. The architect wants to be, I want to control the entire context, and that's what you're saying. Give me the entire context window.
Exactly. Yeah, I mean, I always think, and this is the thing I'm becoming more of a preacher, that actually, it just unlocked you. You know what I mean? Now you have the power, without the emotion, without the thing, to ask the relevant question and give shape to your thinking of the thing that is
And
going
I
to
think
come
it makes a
about.
lot of sense. I think it's what the skill of an architect is. They have there are many factors that go into making decisions about what to do.
Yes. I mean, they're confronted with they don't have a choice. You see what I'm saying? So now, if something is coming about in front of them, like TwinMaster Archie, that is helping them the friction is going away. You know what I mean? The cognitive gap is gone, right? Now they can express and say, I see, if I decided this, if I give this kind of a curvature, I'm going to this kind of, right? It just changes the way you work. It just transforms them.
The design process is a relationship with the client until it becomes a transaction. And then we're going to do that all over again. But the thing that you're talking about, and I've talked about this previously on the Troxel podcast, is like this a potential to continue the relationship, right?
Exactly.
And to
That's what
continue
Michael
to
said. Exactly.
offer insight and help those clients
it's like
get better over time.
Yeah, it's basically what you did was you embodied your intelligence into the twin, and it's carrying its journey, into the construction. It is, becomes now, I don't have to be there. I already have given that. You know what I mean? When it is in design, this guy is going to talk for on behalf of me. It's like that, whether it's in the construction, in the operation, or whatever maybe the life cycle. Maybe.
I think it makes sense. I think, Michael, you're right. It's like the opportunity to create a new revenue-generating business model for the architects that are out there to say, we shouldn't be as transactional as we have been in the past, and can we have a deeper, longer relationship? And if this becomes part of embedded in that twin is you, right? As part of carrying that information forward.
The soul of the architect.
So I've got a somewhat technical question, and then we'll be a little bit pragmatic about the TwinMaster implementation of this. But when you, Prasanta, when you were talking about the data coming, say, geometry from one of these systems into this neutral ground in order to use the AI agent or do this analysis on, think something as simple as like a wall is just two planes, whereas in reality that is a composite, complex system, right, with a lot of things.
Yeah.
So how do you, if you are bringing geometry from one of these systems over, are you basically tagging those with deeper information that you don't have to model it? You don't have to, in reality, you don't have to physically model everything. You just need to reference what this thing might look like. How do you do that?
So it boils down to, again, in the world of, so when you think about common sense reasoning, most of the time, common sense reasoning about is some kind of a semantic framework, an ontology, right? What's a wall? It has occupied space, it has materials, it has some structure, right? All of these things comes in, right, into the picture. So when I'm bringing into this, into my thing, first and foremost, again, going back to my this idea of a system that there's the whole system, like let's say the structural system or the architectural subsystem, which has component of parts, in a physical sense, parts, right? And their relationship, and each part is now having a more deeper information, and it grows, keep in mind, right? Because what it starts as journey at the, let's say, in the Revit environment or an ArchiCAD, when I bring it in, I give more meaning. But as it grows into, let's say, I'm doing, quote unquote, the carbon footprint, I am now putting causality of saying that wall situated in this particular floor with this kind of an environment is causing XYZ heat loss. Some sense of this, right? So that's the meaning. It is taking more and more meaning down the line, so that now you can say, hey, wait a minute, I'm using this material and it's causing this.
Okay. But are you mixing, like, could that be a geometric representation, but then also a document that describes the properties of that material that are connected to each?
Definitely it is, right? So in the I won't say the good old days of So if you look at AI has grown from symbolic AI. The AI if you look at AI has a multi-dimensional aspects of it. AI, there's this big, you can say, group of people in the circa 90s to this called symbolic AI, representation. The word is, how do you represent things of the world? How do we represent things, right? So there's this, it's all about semantics. Like, how do we do grounded? How do you do common sense reasoning with it? Okay, so there's that aspect of it. And then, goes into other kinds of things about, hey, how about, AI as search, AI as reasoning, this kind of an operational sense, right? So the representational side of things in AI, people have put, PhD after PhD has gone in there, right? Which is, how do I structure, right? And you see this in even in neural nets, right? When you look at a complex construct like a wall, what's the right how do you organize? There is different pieces of information. Is it a monolithic document, or is it if I put a neural head on it, it's like saying, okay, I got a token for this, I have a token for that, I have a token for that, and they are related in this manner. I'm just giving you, right? Yep. Obviously, if you boil it down, obviously it will have a binary vector. But at the symbolic level, so when I'm looking at a wall and its representation, I am looking at a little bit what they call as a structured representation rather than a clean document. I could have done that. I could have created a more description. I do that when I'm facing the user. That means I have to create a report or something that's easy to generate. But for my efficiency of reasoning, to be able to generalize, to look at the causality, what contributes this thing, to make it more efficient, I need a little bit of more of a graph representation of that. There are multiple benefits to that, right? And I'm again not going into the part to do the training and learning that goes in there, right? Because what I've done is I have parsed the representation into these little pieces of information. I have basically, I've talked about a semantic aspect of it, okay? And then there's a very important reason why you could ask, why do you want to do that? Because it's at the end of the day, if you look at how we work, it's all about, I would say, context, where is my attention? What is the semantic thing which is kind of giving me where I want to pay attention? Is it the wall's structure? Is it the wall as an insulation material? Or is the wall as a concrete mass and as a cost, right? So these are different kind of semantic thing, and it has a spelling activation, the way, the encoders, decoders work to generate information. So that's the reason why we represent more structure, so that they are easily amenable to grounded reasoning in an AI sense, right? And then furthermore, they are easily amenable for tuning my AI models.
Yeah. I was going to say, so are you all training your own models are you training your own model?
I know. So you could have, this is another thing that we initially, very, very early on decided, not yet, I would say. I would use the word more in a tuning sense and more in the, how would I say, it's like, how would I create more, it's like, I'm not focusing more on what is called as what Anthropic is doing. Give me the context. Make sure I got the context right so that I can make correct reasoning, more effective reasoning, that kind of thing, right? So that part of the contextualization of, have put a lot of effort in there for multiple reasons, because I want to be focused on this goal, right? What's the context in which I'm properly? So we are not, going back to your question, not creating our models, but focusing more on the existing general purpose ones and creating contextualization as a way to make it more tuned, and then compiling that contextualization into the thing, into further tuning.
So that's a good segue to what I was going to ask second, which is, if you're then fine-tuning, what did you all end up focusing on first as a target problem for the TwinMaster could help to solve? Because you can't do them all at once. So was there a specific area that you all chose, and why?
I think that's something is in the works, I would say, in the sense we are because we had to make a conscious decision initially that let's complete the reasoning framework, but before putting more effort on optimizing the tuning process. You know what I mean? Like, hey, which ones I need to, where is the most value add from an efficiency standpoint, okay, kind of thing. And so a couple of things that we are now have initially focused is like more to do with creating the graph structures that can feed into the tuning. And so when I say graph structures, is basically saying, like, do I have the right, so if you look at token, right, text is one single word as a token, right? But I can create tokens which are kind of a graph. This is related to this by this, right? So that I can generalize, okay, from a causality, that this causes this, that causes that, right? And therefore, I'm going to basically get a big cost hit, right? So where the focus has been for the tuning standpoint is preparing the data that I can then feed into this, today's open source things that we have been looking into.
Right.
I can add a little bit to that too. I think to your question, you can't do everything at once. That's just, it's from a production perspective, it's inefficient, and also you can't assume too much without having real experience on real projects at real firms. So we did make some assumptions in the beginning. We focused on certain performance metrics before others, and now we're focusing, as Prasanta said, on tuning and optimizing and trade-offs among those. And where we're at is we kind of have what I call a mature MVP, if that is an oxymoron. And we're at that stage where we're putting into the hands now of all kinds of firms, big and small, to give us their feedback so we can further tune our priorities. But we started off with energy, carbon, compliance, constructability, cost, clash detection, daylight, risk, and radiance. And now a new one that's got added thanks to chaos. Well, there's about 15 more that we could be working with.
That's a lot, though.
So you couldn't do them all, but we couldn't just do one or two either, because that wasn't an adequate representation of the complexity of the problem. So working with chaos recently, they've now added comfort into the mix, because that's a big concern for how they're approaching the world. So we will, we're going through this process of evaluating what the priorities are, because what I've found is that despite the way that architects design, some of these considerations are kind of fundamental to the practice, So whether it's a fancy Frank Gehry building or it's a more mundane big box retail or hospital building, there are these basic considerations that all buildings have. And so we're still going through a process of studying and optimizing, and that's going to continue for a little bit. I think we have to continue to work with firms the way we've begun to, and answer some of these questions. So I see we've got another, we've been around for 3 years. We're at a strong MVP at this point. I think it's probably another year plus before we've solved some of these issues the way we want to. We're calling our formal launch is actually going to be, we're taking on customers, but we're not really going to be scaling up until next year. We're still going through this process of making clients happy, getting their feedback and incorporating it, and getting our software partners content with what we're producing for them, getting introduced into their partner and customer networks. And so there's still some work to be done there before we really can put the pedal to the floor and try to scale this. There's still some more lessons, I think, to be learned for us. So, but the good news is that you can get your hands out of the software today, use it and derive value. And so that enables us to form commercial arrangements with these companies, and we're now in the process with several of them of engaging with their customers for the first time, and it's a learning process right now, to be honest.
So, like you mentioned compliance. There's been a couple of companies that have talked about trying to put their arms around all of that. Is your all's approach to let the customers bring their own data to bring into this, so you're not gonna be responsible for touching what all the right code compliance, but if somebody can connect, point to or connect to wherever the code compliance are you able to then bring that into the context model and
So yeah, I think it's a combination. I would say one is what I call it as is like a kind of give me a generalized compliance model, a generalized compliance model. That means I have structured it. It's like top down, bottom up, right? Top down means I can infer based on these on your building that these are the compliance components. Okay, number one. Number two is that if I then instantiate it or ground it based on the building, okay, on those components, right? As I said, it's a generalized. I'm tuning those compliance things, but I want to do two things. I want to get validation from the user, number one, or validation based on his data about the compliance. Okay, so it's like top down, bottom, right? You're grounding it. You're bringing in a kind of a common framework, a schema, as one would say. That way, I'm not, I can always work with that schema. I can tailor it, customize for this location and this architect and his building versus that building, okay? And that's been kind of the general framework that I've worked with. This is again coming from Lockheed days, okay? Lockheed is, I'll give you an example. The people used to hide their, you can say, all these engineering tools in these Excel spreadsheets, okay? I had no clue. I was to struggle to get it out of their computer because I wanted to create a twin that cuts across, no crevices between, a mechanical guy and a solar power guy, right? And there was no common framework, okay? And that's why we're saying, hey, if I create a common stack, a generalizable framework, a schema, that I'm generating literally, you can say dynamically on demand and design time. So there's this trade-off that you'll see in AI. And this is another thing that I wanted to kind of share with you. This is a strong thinking that I have. There's a design time AI versus runtime AI, right? It's like how many joules are you doing every time you hit and do something versus design time, you create an optimal kind of a thing and you continue to, tune it, adapt it, you configure it like that, okay? That gives you delta energy cost, right? Maximum reuse, right? And that's the thinking, which is that, hey, I have, I can sit on it, I can experiment, I can see how this thing, from a systems angle, this looks good, it's solid, it has the, flexibility, it has the right components, the right modularity, right? These are engineering principles I'm assessing that guy, right? And then I give it to the agent, and as the agent is, exercising it, it's tuning it. Obviously for now, from a reasoning standpoint, but further tuning it into the into the bit vectors, into the binary.
So what's the next thing that you think you're going to tackle? What's the next
what's the next? Or should I give
get
out
the
I don't know.
MVP.
My
We both answer that differently. I think that Prasanta could answer, maybe you should first, about technologically and future-wise what you want to see happen. I'll talk a little bit about how I want to see this scale. So go ahead, Prasanta.
I think a couple of things. What's next coming in is take this, the digital twin and Archie to do more of this spatial reasoning, the world of spatial reasoning, okay? Because it's a physical world. So whether it's for, am I designing for safety? Is this guy, the heat pump that I've done, right, because of the way I have, set it up, is there any pressure drop? So this is basically reasoning about flows, reasoning about the spatial environment in which one, finds itself in a built space, right? So that will become more and more one central theme. It's where Archie will take more, you can say, more meat, I would say. The other thing that I've been, thinking very hard today when we light up, that is, the interaction is with the building, but the building is now showing it in 3D. You see what I'm saying? Whatever, you can say, its assets, its carbon, right? It's like the heat map so that if the data, the inferences are anchored in the physical space, 3D space, right? So today, the way we do that, grounding is all great, But then there is also room for giving you more finer fidelity. And this is you'll hear this called Gaussian splattering and all things go. There's like this fine clouds, which gives you more higher resolution. It gives you a realistic feeling. So that's another direction it would take. But then there are other ones that are that I don't know how much to say. But the idea that I'm after is that there's a lot of build spaces, right, kind of thing, right? And when I go into a building, just as I form my model of the building, I can immediately get ideas of how I can change. Hey, if I change this and this, it'll get a different flow, right? So my question, or you can say a challenge problem that architects face is, am I going to do the whole thing from scratch and redo this thing? No. What I want to do is actually become more powerful in, you can say, I'll use the word reverse engineering the design, right? Out of what you just saw, Archie got some pictures, it reverse engineered, created a model for you, and it gave you the options. So that's the kind of the direction, 2 or 3 directions that Archie is going to take, but definitely I think putting Archie, center and front, immediate future, is really get this thing into them, solve some hard problems this architects face. Right? Make them a good assistant, a good companion.
Well, I think what you just described is, I've been saying it a lot lately with interactions with AI, that it's definitely easier to edit than create. And one of the nice things about AI, and I think what you were just describing, was why start from scratch? You don't want to start from the basics. Give me something, and then I can go to town.
I'll
shape it, and I'm seeing it. I'm using I'm using ChatGPT a lot, just in trying to get the business model, what are we trying to do, all the way from what does the product look like to how do you describe what the problem is.
Yes,
and it's amazing to work with these new tools because, I'm one of these guys. I feel like when I'm around somebody like you, Prasanta, I realize how much I don't know, but I always consider myself a reasonably intelligent guy. But it's like you start interacting with this and you're like, oh my gosh, it is smarter than me already. In a very generalized way, because it can take a large amount of context and begin to put it into a form that is digestible by me, that I can respond to and shape.
So
and I think
a little bit. So Randall, I'll make a correction there, Randall. It's not that it's smarter than you. What if we grew up in siloed access to information? Okay. So I always look at my growing, right? I used to use it microfiche and digging into narrow this thing scripts, right? Then came computers, then came internet, then came DAML, semantic description, right? All on and on till AI, right? So as each one, evolution came, access to information, right, became easier. That means I can quickly get it based on my intent. If you look at that's what Archie is doing.
Right.
So what was not possible, what was kind of a silo, right? And you had to really struggle. It gave you, if you ask the right question, you're asking the question, you are always smart already. It's just that you did not have the power to get to that information.
Yeah. No, you're right.
Now, exactly. Now it operationalized the information, percolated. You know what I mean? It basically, they call as the small network. It penetrated the network, brought the information to you in a cogent and relatable manner.
Yeah, and it's good. The first prompt is pretty good. I think it's going to be people giving them then the control to shape that and to do something with it, personalize it, make it their own. And I think we're at the very beginning of a whole new wave of what this is going to look like, right?
If AI were an alphabet, we're still at A in the AEC industry.
That's right. That's right.
I just some practical next steps for us throughout the rest of the year. We have about 75 AEC firms in our beta program right now. Mostly A, some E, some C, varying sizes from tens of thousands of employees to 200. So we're getting feedback from a lot of folks. And one of our goals is to continue to learn from and with them to satisfy the needs that they have. We're getting a lot of questions at this stage which are can it do this, can it do that questions. So that's an important part of the growth process for us. What's lovely about working with architects and engineers in particular is that they're in creative professions. So we get a lot of creative suggestions from them. And, I must say that's been very helpful to us for sure. As we satisfy the needs of these firms, one of our goals is to build up a portfolio of case studies so that as we get into 2027, we can very practically show people that we did this on this project, we did that on this project, this is how you apply it, these are the results, this is what you would have done, this is what you do now, that type of thing. Then simultaneously, we want to set up these new AEC firm partners for success, which means we're actively working with the ones that I've already described to you to integrate with their existing tools. And they have structured processes, all of them. It takes many months to get through this process from identifying if there's interest, bringing the right people around the table, beginning the technical integration, evaluating the technical integration, testing it with their customer base, and then it goes to market. So we're in various stages of that process with a number of companies, and that's going to continue for the rest of the year.
You end up wrapping, just from a business standpoint, because a lot of what, I run this company, which is like a content management platform that's being used. And, what we found is that, change management inside of an organization is the hard part. The people part is the hard part, not the technology. So do you end up kind of wrapping, I'll just say, professional services around what you're doing, or is that a way that you're thinking about? Because you're talking about changing the way that they're going to design or use these tools to do their work every day, or not.
We're not really, rather. We're not really going to. We have a small portion of our business that will be professional services driven. And that's really because there's a small market out there for standalone digital twin projects that are things at scale, and we will undertake those on a case by case basis. But primarily, what we really want to do is build out a replicable solution that is self-serve, so that our partner clients can run with it on their own, right? And that's the process we go through during the integration phase, during the testing phase, during the customer evaluation phase. It's longer, but by the end of it, you've really proven everything before you go to market. And that's kind of what you have to do to be successful. Subsequent to that, you need to, there's going to be some marketing involved, because as you know, we can be in the Autodesk marketplace or the Trimble marketplace. That's a great place to be. But if you, again, look at the hard numbers, 80% of the tools in those marketplaces don't really get a lot of traction. So you really have to call attention so the market knows that you're one of them there, and that that they know where to go find you if they're a Revit user, or if they're a SketchUp user, or if they're an AutoCAD user. So there's all that to consider too. So there will be marketing behind this that will be creating awareness of what Archie brings to the table. That's going to have to be built up too as far as this year kind of rolls on. We really see this as, if we do our job right this year and we execute, we really see this as scaling in 2027 and beyond. We'll end up with maybe 5,000 seats by the end of the year, but we like to get to, 75,000 seats by the end of the year after that. So there's a plan to kind of move quickly once it all works. So we're still in this phase of setting up for success first, and then rolling it out with scale once we get into that kind of position.
Great. Well, this has been fun. I could talk about this stuff all day long. And thanks for coming on, and Prasanta, thanks for sharing. You've got deeper technical understanding, because you've been doing this for so long. And I'm sure this has been exciting the last couple of years, just seeing the last 5 years really, what the LLM development has opened up, right? All these possibilities of things that you've been thinking about over all these years. It's just unlocked all kinds of possibilities and value, I think, in the market. So I'm glad to see you guys working on it. And I mentioned that we're doing these Confluence events, one-day events, and it just so happens that this year we're going to be in Seattle, which is where you live, Prasanta, and we're going to be in Chicago in May, Michael. So looking forward to connecting with you guys at those events. Any last comments or thoughts, Evan?
No, this has been a great conversation, and I, the thing that I'm beginning to kind of try to wrap my head around is the whole idea of kind of spatial awareness linked with AI, right? Because large language models being language based, and then kind of this link to the real world. I mean, I'm truly fascinated by the challenge that you guys are undertaking. And I think that this really is kind of, I mean, that's going to be a big leap when that happens in AI and technology in general, is that kind of spatial reasoning, spatial understanding.
Absolutely.
And the environments that things sit in, because I think as architects, a lot of times we think about it as the project ends at the property line. But in a campus situation, I mean, that property line is just an imaginary line. I mean, property lines are imaginary lines, right? But there's vegetation, there's trees, there's other buildings. They have, stacks on them that are blowing out stuff from the chemistry lab and all of these things. And all of that matters when it comes to the kind of analysis and reasoning and, decision-making process that goes into digital twins. It's much larger than maybe a little building on an island in the middle of a lake, right? So very different context for every building, and all of that kind of just starts to elaborate on like the complexity that exists in the built environment and how this kind of technology maybe fits into that overarching problem. So
there is, if you look at the one school of thought that is now evolving, this notion of regenerative design. Right, regenerative design thinking and the foundations that we are creating is actually rightly suited for that. When I said predictive, is like basically I'm looking at that as from a regenerative standpoint. Right? I'm thinking how can it contribute in a better way, right, in a harmonious way in that ecosystem. So that's like and if you don't think it right from get go, you could be doing a patchwork. You can't happen that way.
Well, thanks again for joining us, and looking forward to seeing you guys when we're on the road in Seattle.
I'd love to meet you and have a great conversation one more time.
All right. Thanks, gentlemen.
Thank you too.
Thank you.